Hi, I'm Carl, and in this video we're going to go over questions 27 and then 28 to 30, section 3 of the blue booklet. So this first question is a quick question about these circuits which I've drawn out, and I've drawn the three of them out here, and it says which of the four bulbs would be the brightest. Okay, so what affects the brightness of a bulb? It's going to be the current, and this question really examines what you know about series and parallel circuits and how current and voltage can change between them. So current is going to be the same in parallel arms of the circuit. So this bulb and this bulb will be just the same brightness as each other, but the current will be split between this part of the circuit and this whole part of the circuit. So 3 and 4 will have different brightnesses, and it'll be split between whatever current is provided by that one cell. So they're not going to be as bright. 2 then has the same issue where the current is going to have to be split between these two. So each of these cells, we're told, are identical. And so we can say that these two sharing the same current means they're going to be half as bright as this particular one here, because the current is going to be the same with these two bulbs, and these two bulbs will get the whole current of the cell. It's not going to have to share it because they're in parallel. They both get the same current, and so number 1 will be the brightest. And so the answer to 27 is going to be A, this one here. Okay, so moving on to the chemistry question, which is about rates of reactions. We're going to look at questions 28 to 30 now. And I've drawn out the equation here that we're going to be talking about, and this is about the hydrolysis of sucrose into fructose and glucose. We're given quite a lot of information about the rate equation and how logs can be involved in that. We're told in this question that we should let the rate of the reaction at pH 3 be R. So we'll call that R at pH 3. If all the variables are kept constant except that the pH is changed to 2, then the rate of the reaction would be what? So if we're changing the pH to 2, we're actually increasing the concentration of the hydrogen ions by a factor of 10. And because the reaction is first order with respect to H plus ions, that means the rate is going to multiply by 10 too. So the final rate at this pH is going to be 10R. And that gives us an answer for this one of B. Okay, so 29 then gives us a graph, or sorry, a table for the reaction R plus T, or R plus S is T. So we've got our two reactants here, and we've been asked what the rate law for this particular reaction is. So comparing experiments 1 and 2, we can see that we double the concentration of reactant S, and that has no effect on the initial rate. And so we can say that that's not in the rate law. The concentration of S doesn't affect the rate of the reaction at all. If we compare experiments 2 and 3, we double the, well, we'll compare actually 1 and 3, just to keep everything the same. We're going to double the concentration of reactant R, and we're going to keep the concentration of S the same. So we're only changing one variable here, and we can see that when we double R, we double the rate, and there's this 1-to-1 ratio, this 1-to-1 relationship between the rate and the concentration of R. And therefore we can say it's going to be first order with respect to R. So we can say that the rate is going to be a rate constant multiplied by the concentration of R to the power of 1, because it's first order, so we can leave it like that and call that answer A. And the final question then is question 30. It says, which one of the following graphs represents a first order reaction for reactant X? So this one's a little bit complicated, so I'm going to draw out a graph here of the concentration of X over time. If it was just the concentration of X itself over time, we would see that it would go down like this. Try and draw that a little bit better. There we go. If we were looking at the log of X, then that would flatten this curve, and we would get a straight line going down like this. And this gives us an answer of C for this. So we've got a couple of graphs that look a little bit like this and that use these units, and that's what we're used to. But if we change it to a log, we expect this to flatten out because it's going to be a log graph, and that means that it's going to end up as a straight line. So the answer for this one is going to be C. So there were 2 units, Unit 8 and Unit 9 of third section of the Blue Book. I hope that helped. Thanks for watching.